Good morning, students. Today again we will continue with the same topic, midpoint theorem and intercept theorem, that is exercise number 9. So now see question number 12. Show that the quadrilateral formed by joining the midpoints of the pair of adjacent sides of a rhombus is a rectangle. So in this question they have given ABCD is a rhombus. Rhombus means all the sides are equal, and PQRS are the midpoints of the rhombus. So they said the quadrilateral formed by joining these midpoints means if we join these midpoints they form a rectangle, means we have to prove that PQRS is a rectangle. So in this again what we will do a construction join first AC. Now if we join AC we can see the triangle. First we'll consider triangle ABC and triangle ADC. So in triangle first ABC, P and Q are the midpoints, and therefore by midpoint theorem PQ is parallel to AC and PQ is half of AC. This is by midpoint theorem. Okay, now we will see the upper triangle ADC. Again S and R are the midpoints. S and R are the midpoints. Therefore, SR is parallel to AC and SR is half of AC. This is again by midpoint theorem. So this is your first equation. This is our second equation. So from first and second equation, we can see that AC is common in both the equations. Therefore, PQ is parallel to SR and PQ is equal to SR. So PQ is parallel as well as equal. So when one pair of opposite sides is parallel and equal, that means quadrilateral is a parallelogram. Therefore, PQRS is a parallelogram because opposite sides are parallel and equal. Now we have proved that this is a parallelogram, means their opposite sides are equal. But now we have to prove that it's a rectangle. So in rectangle also the opposite sides are equal. But in rectangle each angle is 90 also. So what we will do, we have to prove that each angle means angle PQRS are 90 degree. So again we will join BD and we can see that we know SR is parallel to AC. Now let these points are E, O and F. If SR is parallel to AC, that means this ER will also parallel to OF because these are the small portions of the parallel lines. Similarly, RQ is parallel to DB because it's a parallelogram. R and Q are the midpoints and RQ is parallel to BD. When RQ is parallel to BD, that means the RF is also parallel to EO. So when opposite pairs are parallel, that means that ERFO is a parallelogram. So we'll write down here now. As we have proved, SR is parallel to AC. This implies ER is also parallel to OF. And RQ is parallel to BD. This implies RF is also parallel to EO. Therefore, ERFO is a parallelogram because opposite sides are parallel. As we know that ABCD is a rhombus. Now we will use the property of a rhombus, that is angle O is 90 degree. Here we will draw the figure again. Angle O is 90 because diagonals of a rhombus bisect each other at 90. Okay. Now if angle O is 90, that means angle R will also 90 because we have proved ERFO is a parallelogram. So opposite angles of the parallelogram are equal. Therefore, angle R is equals to angle O. Both are equal to 90 because opposite angles of a parallelogram are equal. Okay, now angle R is 90, therefore angle Q is also 90. we will use the property co-interior angles. Similarly, angle P is also 90 as well as S is also 90, as PQRS is also a parallelogram. So their opposite angles are also equal. Therefore, this implies angle R plus Q is equals to 180 co-interior angles, as these two lines are parallel. Angle R is 90, that means angle Q is also 90. So similarly, angle P and S will also be 90 degree. This implies angle P is equals to Q is equals to R is equals to S is 90. Therefore, PQRS is a rectangle because their opposite sides are equal and each angle is 90. So, hence proved. Yes, the next question is question number 14. ABCD is a trapezium in which AB is parallel to CD and M and N are the midpoints of the side AC and BD. Prove that MN is half of AB minus CD. So children, in this question they have given ABCD is a trapezium, that means AB is parallel to DC. M and N are the midpoints, and now we will do a construction. We will join CN and we will produce this line which meets AB at a point E. So construction, join CN and produce it to meet AB at point E. Now what we will do, we will prove the congruency of these two triangles CDN and ENB. So in triangle CND and triangle BNE. So in these two triangles we can see the two lines are intersecting. So angle 1 and angle 2 are vertical opposite. These two sides are parallel. So we can say angle 3 and 4 are alternate angles, and N is the midpoint of BD. That means BN and DN are equal. So angle 1 and 2 are equal because they are vertical opposite angles. Angle 3 and 4 are alternate angles, and DN is equals to NB, which is given. Therefore, triangle CND is congruent to triangle BNE by ASA axiom. Two angles, one side and side lie between the angles. Why we prove the congruency? So that BE will be equal to DC by CPCT, as well as CN is equals to NE also by CPCT. So BE equal to CD and CN is equals to NE. Both the remaining sides are equal by CPCT. Now CN is equals to NE means N is the midpoint of CE. Now we will see this triangle, in triangle ACE, where M and N are the midpoints. M is the midpoint, it's already given, and N is the midpoint of CE that we have already proved. So therefore MN is half of AE by midpoint theorem. Here, how to get AE? AE is AB minus EB. AE is AB minus EB, that will give us AE. So we will replace AE with AB minus BE. And we know that EB is equals to CD, as we have proved earlier by CPCT. So AB minus, we will replace BE with CD. Here write down, because EB is equals to CD. That's what we have to prove, that MN is half of AB minus CD. So it's hence proved. Yes, children, next questions are based on intercept theorem. So before starting with the intercept theorem, we should know that what are intercepts. So suppose AB and CD are two straight lines, and there is any other line which intersects these two straight lines at a point P and Q. So the line segment, this PQ, is called the intercept on line L made by the lines AB and CD. So basically PQ is the intercept. Now we will move to the intercept theorem. If a transversal makes equal intercept on 3 or more parallel lines, then any other line cutting them will also make equal intercepts. So what is given in this, that there should be 3 or more than 3, but the minimum requirement is there should be 3 parallel lines. So let L, M and N are 3 parallel lines, and there is one transversal. Suppose this transversal name is AB. This transversal cutting these 3 parallel lines and making the equal intercepts. So their intercepts made by this transversal is LM and MN. So if one transversal is making equal intercept with these 3 parallel lines, then any other line which cutting them will also make equal intercepts. So if we will take the another line, suppose PQ, so this PQ will also make equal intercept. So that means suppose this is L1, M1 and M1. So these intercepts will also be equal. So this is the result of intercept theorem. So based on this theorem, we will do the next questions. So see question number 15. ABCD is a trapezium in which AB is parallel to CD and E is the midpoint of AD. EF, if EF is also parallel to AB, meets ABC at F. Prove that F is also a midpoint. So you can see, children, in this AB is parallel to DC, it's given. E is the midpoint. So DE is equals to EA. And they said EF is parallel to AB. Now if EF is parallel to AB, that means EF will also parallel to DC. So we have to prove F is the midpoint of BC. So here, children, we can easily use the intercept theorem, as we can see all the 3 lines are parallel and BA is the transversal which makes equal intercept. Equal intercept, you can see that DE is equals to EA. So these are the intercept between the 2 straight lines. Okay, so similarly, if one transversal is making the equal intercept, that means the other will also make the equal intercept. So here in this question, we will use the result of intercept theorem directly. So first we will write down AB is parallel to DC and EF is parallel to AB. Therefore, AB is parallel to EF parallel to DC, and DE is equals to EA. It's given. Therefore, this implies CF is equals to FB directly by intercept theorem. Therefore, F is the midpoint of CB and hence proved. So here we can see we have used the direct result of intercept theorem to solve the question. Now see the last question. 2 points A and B lie on the same side of the line XY. If AD is perpendicular to XY and BE is perpendicular to XY, meet XY in D and E respectively, and C is the midpoint of AB. Prove that CD is equals to CE. Now here also we will use the concept of intercept theorem. So see, first we will do a construction. We will draw a line CF which is perpendicular to XY. So draw CF perpendicular to XY. Now if CF is perpendicular to XY, now rest we can see AD is also perpendicular on XY, BE is also perpendicular on XY, as it is given in the question. Okay, it's given. That means all the 3 lines are perpendicular. That means their corresponding angles are equal. This implies when corresponding angles are equal, that means all the 3 lines will be parallel. So this implies AD is parallel to CF, parallel to BE. Here we can say because the corresponding angles are equal, that's why the lines are parallel. So now all the 3 lines are parallel and AC is equals to CB. It's given in the question as C is the midpoint. So AC is equals to CB. Why they are equal? Because C is the midpoint of AB. Now children, if we'll see the 3 lines are parallel and the transversal AB is making the equal intercept with all the three lines. That means the other transversal xy, or you can say DE, will also make the equal intercepts. Therefore, by intercept theorem, DF is also equals to FE. As you can see it in the figure also, that these three lines AD is parallel to CF, parallel to BE, and these two are equal intercepts. Therefore, the other transversal, this which is cutting the same three parallel lines, will also make the equal intercept. So first part, F is the midpoint of DE. Now we will consider these two triangles and we will prove the congruency of both the triangles. So in triangle CFD and triangle CFE, first is both the angle 1 and angle 2 are 90 degree. Second, DF is equals to FE, that we have proved. And the third part, CF is equals to CF, that is common. So we need three conditions for congruency. So the given triangle CFD and CFE are congruent by S axiom, two sides, and the angle lies between both the sides. So why we have proved the congruency? So that the remaining side CD is equals to CE by CP CT, and hence proved. That's what we have to prove. So children, based on today's concept, please practice the rest of the questions of the exercise 9. Thank you.